Welcome to part 2 of our chapter 3 review. So number 5, we aren't given the base of the log, but we are given log of base A of 2 and 3, and we're asked to find log base A of 9/2. So we need to rewrite this log expression, so the only logs we have are logs 2 and 3. Well, recall that the log of A divided by B is log A minus log B. So using that property, we can rewrite this as log base A of 9 minus log base A of 2. So to get it in a form with log 3 in the expression, we need to realize that 9 is 3 squared. Then we can rewrite log base A of 3 squared as 2 log base A of 3. And then we subtract the log base A of 2. So substituting in log of 3 and log of 2, we see that our answer is 0.6053. Okay, number 6, solve for x. You get more credit if you find a common base to solve. So you need to recognize that both 27 and 81 are powers of 3. 27 is 3 to the third power, and 81 is 3 to the fourth power. So we can rewrite this as 3 to the third power to the x power equals 3 to the fourth. Then using our properties of exponents, we get 3 to the 3x equals 3 to the fourth. And since the bases are the same, we can set the exponents equal to each other. And we get x is 4/3. If we want to check on the calculator, 27 to the power of 4 divided by 3. And you see we get the right answer of 81. Okay, number 7, we're going to solve for x. Notice we've got two different log expressions on the left side. So your first step should be to rewrite it as a single log expression. So to get rid of the log, we're going to simply raise both sides of the equation as exponents with bases of 10. So I get 7 minus x divided by 3x plus 2 equals 10. Can multiply both sides by 3x plus 2. And now we're just doing algebra. We want to collect the x terms on one side of the equation. Go ahead and subtract 20 from both sides. Negative 13 equals 31x. So we get x equals negative 13/31. Now, plugging that back in into our equation to check our answer, I get log of, sorry, let me get back to the original problem. So log of 7 minus x minus log of 3x plus 2. And we should get 1, and we do. So there's our answer. So number 8, we've got a compounded continuously problem. So there's the equation we're going to use. Initial deposit of $2,800, so that's our P. The rate is what we're looking for. T is time. That's the 8. Notice we're not given A, but it does say the balance will triple. So A is simply 3 times the original $2,800. So plug in what we know, we get 8,400 equals 2,800 times e to the RT. We said t was 8, so we can write that as 8r. I recommend getting the exponential by itself. So I'm going to divide both sides by 2,800. So we get 3 equals e to the 8r power. We can undo an exponential with base e with the natural logarithm. So I'll take the natural log of both sides. So natural log of 3 equals 8r. And then divide both sides by 8. And I get about 13.7%. Okay, number 9. We've got an equation that models the spread of a flu virus. Here's our equation. How many days will it take for 900 people to be infected? Well, that 900 is our y. So we're going to go ahead and substitute 900 into the equation. So my recommendation is to multiply both sides by 1 plus 990 e to the negative 0.7t. So these cancel out, leaving me with 1,000. Over here, I'm going to need to use the distributive property. 1 times 900 is 900. And then 900 times 990. So we get 891,000 e to the negative 0.7t. So to solve for t, we first need to get the exponential by itself. So I'm going to subtract 900 from both sides. And then divide both sides by 891,000. Now be careful. I know some students working on class today wrote this as 1.122. It's not 1.122. It's about 1.22 times 10 to the negative fourth power. So you need to move the decimal over 4 spaces to the left. So e to the negative 0.7t equals 0.0001122. So we'll take the natural log to get rid of the e. So negative 0.7t equals. Now, rather than typing in the number, I'm just going to say natural log of my previous answer. If you don't remember or don't know how to find the answer, you push second and then the negative symbol. Of course, silly me didn't push second first. So second negative. And so that's the natural log of 0.00011122, etc. So then to solve for t, we divide both sides by negative 0.7. And we get about 12.99 or 13 days. Okay, then our last problem is similar to one from the front. We know that 16 and 8 are both powers of 2. 2 to the fourth is 16th, and 2 to the third is 8. So I can rewrite the left side as 2 to the fourth to the x power equals 2 to the third to the 2x minus 1 power. I get 2 to the 4x on the left side, and then I'm going to need to use the distributive property here. I get 2 to the 6x minus 3. The base is the same, so I can set the exponents equal to each other. Now solve for x. X is equal to 3 halves. So let's check. 16 to the x power is 64. 8 to the power of 2x minus 1 is also 64. So I've checked my answer. If If you have any further questions, please ask me during class time or after school.